okay, which one of the following numbers is rational? Circle your answer. Now, with pi and root 2, these are examples of irrational numbers, okay? Because, you know, if you type it into your calculator, for instance, I've typed in root 2 there, you get a number which actually goes on forever, and there's no pattern to it, nothing recurring, okay? So they're irrational, okay? Pi is the same, 3.14159, etc. goes on forever, okay? Now these here, when you look at this here, you might think, oh, 16, I can square root that, but they're actually asking for you to cube root it. And if you think about it, there's no such thing as, or there's no like nice number in terms of cube rooting 16, okay? There isn't a number where you times by itself and by itself again to get 16, okay? So that would also be irrational, okay? You know, this would possibly be in a non-calculator paper, but you could type in the cube root of 16, and you see, you get something horrible again, right? It goes on and on and on, okay? The fourth root of 20, again, can you think of a number that times by itself, by itself, by itself, and by itself 4 times to get 20? And you can't. This one, though, cube root of 125 over 8, well, if you split that up, that's like the cube root of 125 divided by the cube root of 8. Now, cube root is, if you think about it, times by itself and by itself to get this, well, 5, isn't it? If you times 5 by itself again, you get 125. And you can see the same here for 8. Is there a number you times by itself and by itself again? Well, of course, 2, isn't it? 2 times 2 times 2 is 8. So, and you've got yourself in a fraction, okay? That's 2.5, isn't it? Okay? 2.5, whatever, right? It can be written as a fraction, so with whole numbers, so it's rational. That's the one we're going for. Which one of these is irrational? Okay, now, of course, square root of 144 is 12, so it can't be that one. Okay, square this, you get 9 over, square the top, square the bottom, 9 over 64. It's a fraction, it's rational. Cube root of 64 is a 4. It's rational, okay, because 4 times 4 times 4 is 64. 4 is a rational number. This is rational, okay. You might think it goes on forever, so it can't be, it must be irrational. That's not the case. There's a pattern to it because you've got dots here. It's recurring. You could actually write this as a fraction, right? There's a question on that, isn't there, where it'll say write this as a fraction. So you remember, if you've got to say, well, the x equals this, then you do 10x, 100x, 1000x, and so on, and then you can get it as a fraction. So if you can get it as a fraction, it's rational. Of course, this is the one here, pi squared. Pi is irrational, yeah? 3.14, blah, 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 blah. If you square it, it makes no difference. It's still horrible, right? So that's the one that's irrational. Pi squared is irrational.